Well, I've got bad news for you. Somebody got 100.
Okay.
That is right. Yeah. Yeah. So now you've been dethroned. Okay. You're now in second place.
Okay.
You need to step it up. Okay.
But the Korean guy.
Korean girl.
Yeah, girl.
It's a girl.
I know who got 100%. Not the Korean guy. The Korean girl. Oh, maybe she's not Korean. Why are you so shocked?
Because they met John. That's no Korean girl.
Okay, I'm sorry. She's not. She's the one that transferred from science. There's two of them that came from science into physics. Sorry, you're right. She's Malaysian, not.
Wait. Oh, Malaysian.
Yeah.
Wait, got higher.
Wait.
Which one?
Are small girls not allowed to get 100 or something?
No way. A small girl with big brain.
But I don't want to burn in science.
No, physics.
Physics.
Got 100 in the physics.
Physics midterm
The
test.
same test.
Yeah, the same test.
Lame, I touched that.
What did you get in that physics test?
I have forgotten.
Yeah, wasn't 100 though.
No.
There you go.
Because we have a tutorial, probably go to check the tutorial, but yeah.
Hater. That's what you are. Right.
No formula book.
Oh, I did let them use a formula book.
That's
right.
If we use formula book, we all got 100.
Sure.
There's no science
Sure.
student.
Continuing. You can show them your respect later. Right. So, earlier in the chapter we were talking about how, with the product, quotient and the chain rule, we can differentiate any function. The problem of integration is this. Some functions you actually cannot integrate. They have no integration. Even functions that look quite simple. So if I said to you, okay, integrate this, well, that's easy. It's EX plus C. And if I just do this little change, now you can't integrate it. No method that you have, or no method exists to integrate this.
Yeah.
No, you see, when your teacher says no method exists, there's no answer. This is not for you to try and give an answer.
Oh, but we can
No.
differentiate that.
We can differentiate it.
But no.
We cannot integrate it. Amazingly. So we can use the chain rule to differentiate this. We have no way. In fact, there is no function that we can find that when we integrate EX squared we get this function. It doesn't exist. Or another way to put it is there's no function so that when we differentiate it we can end up with EX squared. This function does not exist. So this gives us a problem. What could I do if I wanted to integrate something like this? Like if I needed to integrate this, no substitution.
Oh, I know. This is Trapezium rule.
Correct. And what is the Trapezium rule? Okay, continuing. So, you need to remember a useful fact, that integrating actually gives you the area under the curve. So you can change the integration problem, which is not solvable, into an area problem, which although not solvable, you can get a rough answer. So let's have a look at the idea. We imagine we have some function we want to integrate, let's say from A to B, and I'll just draw the function like this. And we want to integrate from A to B. So this means I'm trying to find this. And we can say that this is equal to the area as shown here. And this will be the trick to getting a rough answer. Because what you can do is you can change this into many little rectangles. Yeah, so what you can do is you can draw a straight line up here, and draw a straight line here, and then draw a straight line up here, and go like that, and go like that, go like that, and go like that. Yeah? So let's just get the area of the first piece, okay? So rather than looking at all the pieces, let's just start by looking at a small piece here. So we'll just call this A and this B, and there's only one piece, okay? So if I look at this shape, maybe it makes a triangle. The area will be the base by the height, which is FA, because it's going to be this rectangle, plus the triangle on the top, which is a half the base by the height. And what's the height of the little triangle sticking up on the top? That's FB minus FA. Can you all picture that? Yeah. So that simplifies down to BFA minus AFA plus a half BFB plus a half minus a half BFA minus a half AFB plus a half AFA. Right, what can I simplify this down to? What cancels here? BFA, have I got another BFA?
Yeah.
Mine's a half BFA, so that's a half BFA. Yeah? So BFA is gone. Minus a half AFA?
Yeah.
AFA, and then what about these pieces? Yeah? We consider these pieces, don't we? Plus a half BFB minus a half AFB. I should simplify this, shouldn't I? I should definitely take the half out. I take the FA out here, and B minus A, and then here take the FB out, and then this is B minus A. Okay, this is good. What can I take out now? I can take out B minus A, and then FA plus FB. Or if you just want to keep it more general, it's a half the end X minus the start X all over, and maybe I'll write this backwards, FB, F the end plus F the start. Not yet there. So this is only getting towards the formula. This gives us the area for one piece, okay? A half the end minus the start. Well, the end minus the start is just how wide it is, isn't it? So I'll just write half how wide it is, and then these are the two heights. So the first height plus the second height. That's all this formula is. A half the width by the two different heights. I'll write actually F1 plus F2. Okay, so now let's go back to this picture. Half the width and then two heights. Okay, so if I go back here, let's make our life easy. Let's just say there are n parts. 1, 2, 3, 4, 5, 6, all the way up to n. And I'll make each piece the same, of course, to make our life easier. So I'll say the width, I'll call that h, and I'll say that's v minus a over n. Yeah? So for example, if this was a 0 and this was a 10, and I had 10 pieces, then each piece would be 1 unit. So let's see what I can say the area is. It's roughly, okay, so if we look at the first piece, a half the width, and then it's the first height, and I'll call this one here, rather than A, I'll call this one X,
1.
I don't know if I want to start with 1 or 0.
0.
Let's start with
0.
0. F, although I reserve the right to change that later. Doesn't matter, I guess. Fx0 plus F, and this one here, x1. Okay, and then the next one, this piece, will be the same. Plus a half h, and you know what, actually, I'm actually not going to use Fx0, I'm going to actually use the letter Fa. Okay, and the next one will be a half h Fx1 plus Fx2. And this continues, we'll do two more, just a half h Fx2 plus Fx3, etc. Now, what's in common here? The half h.
Oh, they're not different H.
No, all these h's are the same. No, h is the widths.
Oh.
Yeah, so a half h, and that's Fa plus Fx1 plus Fx1 plus Fx2, and then the next one is Fx2 and so on, and then finishes on Fb. Now you notice all of these repeat twice, except which one? The ends, yeah. And remember what h is. So this is a half b minus a over n f a plus f b, and then you want to add up f of everything that is in between. So I'll just write the middle here, or you know what? I'll just write f else times 2. Thank you. And this is the trapezium formula. Now, of course, it's not an exact formula. It's only a rough answer. What would you have to do here to make it more accurate? You have to increase the n, because as you make the n bigger, you're making these pieces smaller, and you're making it more accurate. And in fact, if you could make the n go to infinity, the area would actually go to the true value of the area.
Yeah. Then how that become Fn? B minus a over n.
Yeah?
If that n equals to infinity, how can we calculate that?
Beyond the scope of this course. This will go to 0, and this will go to infinity. Together, they don't go to infinity. The relationship is too difficult for us to study. So this is the rule. Let us look at an example. If you can write this down. I think I put it, yeah. I did write middle at the back. Trapezium rule. Can you write this down? And we'll have a look at an example. Do I have my calculator open? I do not.
But we don't have to know how to prove, right?
No.
Okay. So just say that.
What do you want to study next year?
Me?
Yeah.
Computer. That's
Okay.
software engineering.
Okay.
Well, I have to study this.
This actually comes up because this is all computer-based maths, because we're going to be using calculators and Excel. In fact, in your coursework, they'll have you use this formula in Excel. I'll show you how to do this on the calculator. Hang in there, Andrew. I know you're sick. Be strong. Some maths will help you feel better. I don't want this right now.
In Europe, I know what we use for
I think on the back I just wrote middle. I don't actually know what they write in the exam. It's the first plus the last plus twice everything else.
I mean, you said you don't use this rule in our first course, right?
Oh yeah. Oh, I don't mind once I understand your meaning. It's fine. Yeah. Your poor phone, Jeremy, it keeps falling. Oh, good, yes. Continue?
No.
Yeah. Oh. I thought you didn't care about the proof, Lee.
Just 3 lines.
Now, question 1 is the only one you can do without the trapezium rule. But question 2, 3, 4, and 6, 7, and 8. But 1 and 5, obviously you don't need the trapezium rule. But I want to do number 1 to show you how accurate this can be. Can I go on to it?
Yeah.
Sean?
Yes.
Right. So, before I use the rule, let's just check what answer I should get. So this becomes x cubed over 3, 0 to 1, which will become 1 over 3. Okay, let's use the trapezium rule. So, for the trapezium rule, you break it up into lots of little pieces. Okay, so you have a start and you have an end. So, where do we start here? We start at 0, don't we? And where would we like to end? We'd like to end at 1. Yeah. Now, I tell you in the question what to use for n, how many pieces. So what did I say in question 1? 3. Okay. So I'll just write here n equals, and I'll just write here 3. And I'll just write here a equals 0. B equals 1. So what does h equal? That is, let's see, b minus, flip. I know, but I want to type in the formula. B minus a over n. Yeah. So this is the h. But if of course, if I make the n bigger, then I make the h smaller, smaller pieces. Okay, so we're okay with this? Alright, so this is the first piece, 0. That's the start. Where's the next point on the graph?
1.
No, if we're going up in the little pieces.
0.3.
It'll be 0.3333, and the next one will be 0.6666, and then the next one will be 1, roughly. Yeah. So I need to increase by this distance here.
Yeah.
Okay, so that's the next one. That's the next one. Stop. Now I need to work out the f. So let me just put in this is the x and this is the y, or the f of x. Okay. And what's my formula here? It's square, isn't it? So that'll be 0. That's that one. That one. That one. This is f of x. So 0 squared, 1 over 3 squared, 2 over 3 squared, 1 squared. Right, so let's calculate the area. And let's remember the true answer should equal about this. Okay, so the trapezium rule is 1/2 times the h times the first, oh sorry, let me put brackets here. The first plus the last plus twice, and then we add up all the other ones, which are these two added together. Yeah. And we get something quite close. Now, because I'm using Excel, it's not really any extra work if I increase this. So let's put this at 100. Okay, 1,000. Now I need to fix this because I need to go down to to 1.
Sorry.
That's okay. No, don't. Okay, so that is 1,002. Right, so it's a half times h times the first plus the last plus twice the sum of everything in between. I know I can type it, but I want you to appreciate you're just adding all of these up. What? No, go back! No, it's stuck.
Oh, Jesus. Yeah. Come on.
What is that?
Stop.
Can I? No, I see I can't even escape.
Close it. And what? They just take this one. You get the idea though.
It has to stop at some point. It can't increase to infinity.
Yeah, maybe.
You thinking 10,000? Are you going to get the 10,000 wish that you hoped for?
Okay. 9,000. Wow. Slow it.
Is it slowing?
No. Maybe it'll not stop.
It has to stop. Eventually it has to stop.
Maybe.
Alright, let's see.
Yeah.
No.
Okay. Let's try this again. Equals a half
H.
times h. Come on. It's run out of memory or something.
It's okay, you'll get the end of that stuff.
This is because you asked for 1,000. It's fault. Okay. A half times h times the first
And the last.
plus the last plus twice the sum from B3 to B1001. So if I use 1,000, then I actually am pretty close to the true answer. And the reason I say we use 1,000 is because we always have a computer do this, or a calculator, so it's not really any extra work. So in the exam, how could you do this? Well, let's have a look at another one where we can't find the answer. So let's do this one together. Oh, and by the way, sometimes in the exam they might ask you for the error. So of course, if they want the error, you need to know what the true answer is, which they should provide, or you should be able to calculate. So in this example here, what was the error? Let's see. It was this minus this over this times 100. So very small percent. Like that's 1%. Tenth, 100, 1,000, 10,000, 100,000 of a percentage error. Quite good. Now, let's have a look at one like this. So we want to do this problem. Minus 1 to 1 e minus x squared dx. And we're going to do it on our calculator. Alright, so let us decide together what would be a good number of pieces. We don't want too many, but if we have not enough, it will not be accurate. So, from minus 1 to 1,
3.
5, I think sounds good. So, we'll make a table, but first we'll write down our info. A, minus 1. B, 1. N, 5. And H is B minus A over 5, so that's 2 over 5. 0.4 is the H. Okay? And we have a little table here. And this is the X, and this is the FX. Right, so where do I start? Minus 1. Next value? Minus 0.6. Minus 0.2. 0.2, 0.6, and 1. And what's really nice is we don't have to type all of these numbers into this, because our calculator can do this for us. So if we go mode table, we can go shift E minus x squared, and then start at minus 1, go to 1, and increase in 0.4. So our first one is 0.3678, and our next one is 0.6976, and our next one is 0.9607, and our next one will be 0.9607, 0.6976, 0.3678. And the trapezium rule says the area, which is the integration here, so I equals, so I is roughly a half times 0.4, so that's 0.2. The first plus the last, so that's the red piece, plus twice everything else. 1, 2, 3, 4. Plus twice the blue numbers. Yeah? Let's see what we get. First plus last plus twice everything else. What's that? 0.76. I think I got them all. That's just in the middle. So that's 0.2 times 7.3688. So 1.47376. Or roughly 1.47. Let's see how good our answer is by using our calculator to check the answer. .49, and we got 1.47. So we were only off by 0.02, which is just a 1% error. 1% error using a relatively small n. So this would be a typical exam question. Typical exam question. And not that bad if this is a normal exam question. The only other thing they would maybe ask you to do is to calculate the percentage error. So if I do that, let me just see. Oh, what was I having a moment ago? 1.49 or something, wasn't it? Yeah, it's about 1.6% then. the error.
So what if you didn't use the Casio calculator? So you can.
You'll have to type it in about 1.3%, I think. You'll just have to put in all the x's into the function one by one to get all those y values. So what calculator have you got?
Here.
So what are you worried about? And he can do it.
570.
What calculator do you have, Jerry?
991.
Great, okay. So you can make this table. I just showed you. Sometimes in the exam what they do is they give you the table and leave some squares blank for you to finish. So they might leave, like, say, the second one and the third one blank and one of the x's blank.
So this is kind of B question, right?
No, A or B. Why can't this be an A? This wasn't so long to do. Yeah? Huh? Okay, one more time. So you type mode table e power minus alpha x squared. And we don't need g if your calculator asks you for it. Start at -1, finish at 1, and go up in 0.4s.
Wow. How much is this?
About 20 euros.
There's too much. 20 euros again.
Yeah, but
Or maybe 2. No, my computer can do the same thing.
if you go to the cafe on the corner, 20 euros can get you 3 meals.
Oh yeah, true. Or maybe 4. They have like €5 burger.
Do that.
Yeah.
But the calculator will last a few years, so.
You should tell me last time.
4 meals.
Are you not going to buy a Casio calculator?
Huh?
Are you not going to buy this
Well,
calculator?
mine is casual. Just 5.7. Oh.
If I'm going to get a newer laptop, then you should get a newer calculator.
Which you don't, and I don't. Well, no, it's a new old laptop.
Yeah, so you can get a new used Casio 991.
How much is it?
Yeah.
We are asking for like.
You want me to? Did you write this down now? Now this is important as well for your coursework, Jerry. This is important for your coursework as well.
Isn't it the mode table?
Yeah.
And then start with -1 and with at 1 and page 5?
No. The step is how big each piece is, not how many.
Oh, that's
Yeah. This is. No, listen, Chrissy. This is start, this is end, and this is step.
See, teacher, that's a problem.
Yeah?
School relying on calculator without thinking.
Big bad.
Come on, he's not looking.
All the machine is everything for business,
Like me.
including car or laptop.
Or electric skateboard. Look, Jerry, lazy is okay once the job is done. If you get your work done, you can be lazy. Hmm? It's true. Being lazy but getting the job done is just being efficient.
Yeah, true.
So students being lazy. I lazy.
I am lazy and I do lazy.
Sorry?
I got an email about.
Did you write this down, Chrissy?
Oh, yeah.
Chrissy, and did you get the table on your calculator?
Yeah, of course.
Of course.
Oh, cool. minus 1.
Okay. You got that. So.
I mean, our solution to this chemistry is everything. That's a-
Casio.
It's like plan motion.
Yeah, we have two.
Yeah, why not just do numerical?
Yeah, I
I
know.
should
that.
email Casio. I should get sponsorship.
I don't understand that. We have to make an essay, like physics, like for physics.
Oh, you could do a lab report for
No,
physics.
we have to make one for chemistry.
No.
Chemistry essay.
Yeah.
Use nanotechnology, right?
Nanotechnology.
Nanotechnology is why you
Interesting.
organize
The teacher here yesterday, that's what her research is in, is nanotechnology.
But I got only 44 last time.
Well, I didn't know yesterday you were writing an essay on nanotechnology. Okay, we got this? Yeah.
No,
So-
I did 500.
All of these questions, it's the same rule to use. Now, just before we finish this, I just want to point out there are some famous functions which can't be integrated in maths, and we need to use a rule like trapezium. So this is the most famous one that has no method except trapezium. This is next. This one comes up in maths quite a lot in the area of probability. This one comes up in waves, I believe, in engineering. This one here, which also has no integration, this comes up in number theory.
Number theory.
Yeah. This one here comes about when you're looking at the prime numbers. This one here is important because the shape is, I think, like this. It happens when there's a certain type of wave, I don't remember what. And this one here is like this. And this is important in probability because it's something to do with what is called a bell curve, which you maybe have heard of before. Bell curve. A distribution, yeah. Yeah. So the point I'm trying to make is that because these are important, we need ways to integrate them, and trapezium is one way, although the next lesson we'll look at another way that's a little bit better. But you remember that your calculator has an integration button on it. The calculator isn't smart. It's not like it uses some substitution or partial fractions to integrate. It's a calculator, not a brain. So for all those integrations you do on your calculator, it's actually doing the same thing each time. It's using a method like trapezium to integrate. But because it's a calculator, it can do it 1,000,000 times and get the answer accurate to 9 decimal places. Do you understand? Yeah. And this is really important in modern engineering, because a lot of problems in modern engineering require the use of a program, a calculator, or software, because in fact there is no exact mathematical answer. So, since you're all going to be studying engineering, be it computer science or electronic or whatever, it is very likely you'll have one course about numerical methods, which are the methods we're learning about right now, how we can use computers to get answers to integration problems. We don't need a computer for differentiation because everything can be differentiated using the product quotient or chain. But not everything can be integrated.
Teacher.
Yeah.
For the graph like sine S over S, it has like positive and negative. What is
Yeah.
the values like between these and these? I mean between the positive part and between the negative. The A and B.
Oh yeah, it doesn't matter. The trapezium works if the graph is positive or negative. It just means that your integration no longer represents the area.
What?
The trapezium method does not care if it's above or below the axis. It just means when you get your answer, it will not represent the area if part of the graph is under the axis.
But our theory is finding the area.
If we're being super technical about it, it's finding the area but putting a minus in when it's below the graph. Because when we integrate, okay, if we integrate, when it's down here it's negative. If I use trapezium,
It's possible.
No, it's not. It's negative because I didn't use the height. You recall I used f of x. And if x is here, then f of x will be negative. It will become minus in the table. You'll get negative values here if it goes underneath. And that's what we want, because when we integrate underneath, we get negative answers. So actually the trapezium doesn't care if it's above or below. It just means the answer we get here no longer would represent the area.
What if we get in between, like
That's fine.
our starting point is
That's fine. It's fine. It could be like this, it could be like this, it could be like this. The trapezium method will integrate correctly. You don't believe me?
like the n is at negative, it's like negative minus.
Okay, it could be like this. And this could be, and this could be A, and this could be B. And that's fine. The trapezium and the integration will be the same. So much doubt. Or you believe me?
Because it doesn't prove in the...
It does actually. It does, because in my proof,
To find the error.
yeah, I know it's finding the area, but technically it's not quite the area because I used this, and this could be positive or negative. What I'm finding here, not quite the area, we'll call it the area dash, where it means the area but negative when it's underneath. Yeah, I'm sorry. I realize the more I speak, the worse I might make it. You're either going to be happy or unhappy with that explanation, and you are.
Yeah, I'm okay.
It's not okay, I know. That's alright. Yeah. We're finished there, and when's our assessment support this week? Friday? No.
No,
Tomorrow?
today.
Not assessment support. I mean to say, when is our last maths class?
Tomorrow.
Tomorrow's our last maths class. Friday we have physics. How many hours do we have tomorrow? But how many maths? Right. So the plan for tomorrow is in the first maths class I will do Simpson's rule. Then after I do Simpson's rule, I'll give you your coursework and you can start working on it. I recommend that you solve it first by pen and paper, and then you can check your answers, and once you're sure you have the right answer, then you start typing it. Okay? And if you get stuck, I can help you. But once we have Simpson's rule done, we can start the coursework, and then we are at the halfway point, and then it'll be the mid-semester, and everything is on course. Alright.